Temukimanyi nti no waliyo neetaaga okusinga n'ebiteeke.
Good afternoon, sir. This is Graisma. So here we're going to discuss about dimensional modeling and understanding multidimensional analysis. Dimensional modeling involves designing the data warehouse. Is a key data warehousing process. Note, although DW can be designed by entity relation modeling, we need DWH experts, including Kimball, perform dimensional modeling. Dimensional modeling is the process and outcome of designing. Dimensional models are logical databases schemas created to support OLAP and data warehouse solutions. It's especially useful for summarizing and rearranging the data and presenting views of the data to support data analysis. In DAM, the following information is important: dimensional attribute hierarchy. Then the dimensional model elements include dimensions, attributes, and the fact tables. Then dimensional model examples: the analysis of a product sales to a customer during the last 6 months has three-dimensional customer, product and time. The analysis of product sales to a customer in the district during the last 6 has 4 dimensions: customer, product, region, and time. Note, by the rule, the time is always one of the dimensions. Data granularity defines the level of detail of a single record in the fact table. The more detailed the row is in the fact table, the higher its granularity, and vice versa. For example, a fact table contains 3 metrics. The time dimension consists of 4 hierarchy elements. The organization dimension consists of 3 hierarchy elements. The product dimension consists of 2. Then the highest granularity that we can store sales metrics is by data store SQL. Conversely, the lower granularity that we can generate sales metrics to in this data mart is by year, region, product, family. Then steps in designing the dimensional models: choose a business process, choose the grain of the fact table, choose dimensions, choose the measured facts, and then choose the duration of databases. Then we have benefits of using dimensional models. This model is easy to understand. It's optimized for performance, historical tracking of information, understanding dimensional modeling. Here we have a rational modeling and dimensional DM. The difference is, for rational modeling, data is stored in RDBMS, whereas for dimensional, data is stored in RDMS. Then in rational, we use tablets as units of storage. Then in dimensional, we use cubes as units of storage. Data is normalized and used for OLTP in rational, whereas for dimensional, data is denormalized and used in WH and data mart. In rational, it is volatile, whereas dimensional is non-volatile. Then we go to the SQL is used to manipulate data in rational, whereas MDX is used to manipulate data in dimensional. Detailed level of transaction data is used in rational, whereas summary of bulk transaction data is used in dimensional. As you can see, those are the differences. Then dimensional model is a star schema that contains 2 types of tables: fact tables and dimensional tables. The fact table is the primary table in the dimensional model, where the numeric performance measurements of the business are stored. In the dimensional table, it's a table that contains the textual descriptions of the business, for example, product and brand descriptions. The fact table is a table that contains the measures of interest. This measure is stored in the fact table with the appropriate granularity. For example, it can be sales amount by store by day. In this case, the fact table will contain 3 columns. We have numeric, additive, primary keys of dimension, consider rolling summaries. Then we have the dimension table. The dimension table provides the detailed information about the attributes. For example, the dimension table for the quarter attribute will include a list of all quarters available in the data warehouse. Each row may have several fields. One of the unique ID that identifies the quarter, and one or more additional fields that specifies how the particular quarter is represented on a report. Then we have information packages. Here we include business requirements, define the common Civic areas, design key business metrics, decide how data must be presented, determine how users will be aggregate or wrap, decide the data quantity for user analysis or query, decide on how data will be accessed, establish data granularity, estimate data warehouse size, determine the frequency for data refreshing, ascertain how information must be packaged. So this is an example of information package diagram. As you can see, there is year, time periods, location, products, age groups. Then we have example. We have example analyzing business scales, user analysis by product, analysis by breaking the sales down by dealers. As an automaker, you would want to know who is buying the automobiles and what quantities. How do customers for the automobiles? What if it does it finance? What if it does financing for the purchases have on the sales? Identify select dimensions, fact dimensions for the subject or sales for an automaker, which include the product, dealer, customer, method of payment, and time. Hierarchies and categories are included in the information packages for each dimension. Here we have a information package diagram. As you can see, there is year, model name, financial type, age, dealer. Yeah, this is an example of the information package diagram. And we have example. Maybe my colleague will start from there. We have Hotel Serena.
So here in this example, we are trying to understand how to design a dimension model for the given example, Hotel Serena. So in our dimension model, we are going to include the hotel, the room key, and time. Time is a crucial factor that every dimension model has to have. So we are going to look at the hotel line branch called zip manager. We are going to look at room key, time. All these are going to be included in our dimension table. As you can see, the understanding of the dimension model. So types of dimension models, we have basically 3 types of dimension models. We have the star model, the snowflakes, fact constellation model. When we talk about the star model, here the object or the fact table is in the middle, and the dimension tables are connected like a star. And then when we talk about, like, for example, this picture, when we talk about that is all a star model and a star schema. When we talk about, so now we have the benefits of the star model. It is easy to understand, easy to define hierarchies, reduces number of physical joints, lower maintenance, and very simple metadata. And then when we talk about the snowflakes, refinement is just a refinement of the star schema, where some dimension hierarchy is normalized into a set of smaller dimension tables, forming a shape of a snowflakes. So remember, the first we had a star model where we had a fact table in the middle and a dimension tables connecting in a star form. Here now we are normalizing the hierarchy, and then we have the fact table, and then we have extensions of a dimension tables, such as in this dimension table, we have a supply key that extends to the supply dimension. And this is a typical example of the snowflakes model. So what are some of the benefits of the snowflakes? Using OLAP, online analytical process, multi-dimension database, modeling tools that use dimension data maps as the data source, appropriate for use where a dimension table occupies a significant portion of the database. Easier to use. A snowflake schema sometimes reflect the way in which users think about data. Useful in conventional multi-dimensional reporting tools. So then we talk about another dimension or another type of model that we use in modeling. In the dimension modeling, we have the fact cancellation model. It's a dimension model that consists of multiple factual tables joined together through dimensions. So in this way, we have multiple factual tables. So we can see we have the shipping fact table here, we have a sales fact table, and they are connected. It all comes from the star, the snowflakes, and then the fact constellation table. Common uses, then we have common uses of dimension table. You have this should be forward debit query tools. Stuff like schema are often better with more sophisticated query tools and isolate users from the root table structures. For the environment, having numerous queries with complex criteria. So importances of partitioning, we have flexibility in managing data, smaller physical units allow easy restructuring, free indexing, structure scans if needed, easy reorganizations, is recovery of data, easy monitoring. And then why use surrogate keys? Remember, surrogate keys, these enforce referential integrity in the facts table. So why do we use segregate keys? Data tables in various sources may use different keys for the same entity. Legacy systems that provide historical data might have used the different numbering systems than the current online transaction operating system. So a surrogate key uniquely identify each entity in the dimension table regardless of its source of key. A separate field can be used to contain the key used in the system again. Systems developed independent in company divisions may not use the same keys, or they may use keys that conflict with data in the systems of other versions. So that's reasons why we should use surrogate keys. Continuation of the reasons. So what do we understand by the word multi-dimensional databases? A data warehouse is based on the multi-dimension data model. Multi-dimension database, remember, we are talking about dimension database. Now we have multi-dimension databases. Multi-dimension database represents the multi-dimension characteristics of data internally, stores the data in a giant hypercube, or what we call tubes. It makes it easy for the computer to locate any item of interest. So this is an example of the multi-dimension data. And another example in the graphical way. What are data cubes? These are how the data is stored in a multi-dimension database. Data cubes are multi-dimension data sources, allow you to look at data, at complex data in a simple way, allows you to analyze specific data, helps to represent data in multi-dimension data, multi-dimensions, defined by dimension and facts, and dimensions are entities with respect to which an enterprise preserves the records. So that is, we're going to see an illustration of the data cube. This is a 2D illustration of the data cube, and this is a 3D representation of the data cube. So that was our presentation about dimension modeling, understanding multi-dimension analysis, and the presenters were Mugera Isma, Nasa Zijovia, and Bwire Conrad. Thank you, sir. So we stop.